So, hi everyone. Today we are going to see the classification of antibiotics. Okay. So, antibiotics are classification. Okay, antibiotics are classified based on number one, mode of action. Mode of action. Number two, spectrum. Spectrum of activity. Number three, mechanism of action. This is very important. Mechanism of action is very important. Okay. Next, number four, chemical structure. Chemical structure. Next, number five, pharmacological action. Pharmacological action. Based on these five properties, antibiotics are classified. Out of them, the mechanism of action is very important, and in competitive exam, most of the question are asked from mechanism of action. Okay, or classification based on mechanism of action. So now we will see the classification based on mechanism of action. First, I will say that if you want to write, then please pause the video and write down. Okay. So classification based on mechanism of action, that is MOA. Okay. So based on mechanism of action, antibiotics are classified as mainly five types. Okay. Number one is cell wall synthesis inhibitor. Cell wall synthesis inhibitor, which inhibits the cell wall synthesis of bacteria. Okay. Inhibitors. Next, number two is cell membrane integrity disruption. So it is called disruption of cell membrane. You have to focus that first one is cell wall and second one is cell membrane. Okay, so disruption of cell membrane integrity. Okay. Next, number three is protein synthesis inhibitor. Protein, which inhibits the protein synthesis. So when it inhibits the protein synthesis, ultimately protein will not form, and when protein will not synthesized or less protein will synthesized, ultimately the bacteria will show less pharmacological action in the body, and ultimately it can show less effects in the body or less negative effects. Okay. Next, number four is nucleic acid synthesis inhibitor. Again, nucleic acid synthesis inhibitor ultimately lead to inhibition of protein synthesis. Why? Because when nucleic acid will be synthesized less, protein is a type of enzyme. This protein is coming from RNA, and RNA and DNA are types of nucleic acid. Okay, so nucleic acid synthesis inhibitor. And next, number five is anti-metabolites. Okay, anti-metabolites. Now, which one shows which effect? So the first one, that is cell wall synthesis inhibitor, will be shown by antibacteria. Okay, again, this protein synthesis inhibitor will also be shown by antibacteria. Okay, disruption of cell membrane integrity will be shown by antifungal agents. Antifungal agents. Okay, next, nucleic acid synthesis will be shown by antiviral. And antimetabolites will be shown by antiviral also and anti-cancer also. Anti-cancer antibiotics. So these the classified based on the mechanism of action. The antibiotics are classified as number one is cell wall synthesis inhibitor. Next is disruption of cell membrane integrity. Next is protein synthesis inhibitor. Next, nucleic acid synthesis inhibitor. Okay, nucleic acid synthesis inhibitor. Next is antimetabolites. Okay, now we will see the first one, that is cell wall synthesis inhibitor. So example of antibiotics which shows inhibition in cell wall synthesis are all the beta lactam antibiotics. You know it very well. So number one, all the beta lactam antibiotics. Okay. Next, cycloserine. Next, vancomycin. Next, bacitracin. And next, phosphomycin. Okay. So these all are cell wall synthesis inhibitors. Next, we will see the number 2, that is disruption of cell membrane integrity. So antibiotics which will show the disruption of cell membrane integrity are number 2, disruption of cell membrane integrity. In this, number 1 you will see colistin. Okay, colistin. Next you will see polymycin B. Next you will see tyrothricin. Next you will see amphotericin B. Next you will see nystatin. Next you will see ketoconazole and itraconazole. Already I told you these all are antifungal agents, and this shows disruption in cell membrane integrity. Now the most important thing you have to remember, this ketoconazole and itraconazole are azole derivative. They are called azoles. Okay. These amphotericin B and nystatin are called polyenes. This colistin, next polymycin B and tyrothricin are called polypeptides. These are called polypeptides. So these 3 are polypeptides, these 2 are polyenes, and these are azoles. So in azole, in the name or in the end of the name you will see azole C, ketoconazole and itraconazole. Here amphotericin B and nystatin. So in these are polyenes. Okay. Next colistin. In colistin you will see polypeptides. Okay. Next number 3, that is protein synthesis inhibitor. Already I mentioned earlier that this protein synthesis inhibition will also be shown by antibacterial agents such as macrolides, next tetracyclines, aminoglycosides, etc. Okay, so let's see protein synthesis inhibitor. Okay, protein number 3, protein synthesis inhibitors. So what are the example? Number 1 is tetracycline, next aminoglycoside, next macrolides, These all are protein synthesis inhibitor. Chloram, phenicol. Next, clindamycin. Next, streptogramin. Next, linezolid. Now you have to remember the most important point is that these first tetracycline and aminoglycosides, they will bind to 30s subunit of 70s ribosome, and the remaining all will bind to 50s subunit of 70s ribosome. Okay, so right there, this bind to 30s subunit of 70s ribosome, and this all will bind to 50s subunit of 70s ribosome. Okay. Next we will see number 4, that is nucleic acid synthesis inhibitor. So nucleic acid synthesis can be inhibited by different ways, or by using different antibiotics or different agents. We can inhibit the synthesis of nucleic acid. So number 4, nucleic acid synthesis inhibitors. Okay. Number 1, see, first I'll tell you this nucleic acid synthesis can be inhibited by number 1, inhibiting DNA replication. Next, DNA dependent RNA polymerase by inhibiting the activity of ddRNA, that is DNA dependent RNA polymerase. Next, by inhibiting viral RNA dependent RNA polymerase. Next, by inhibiting DNA polymerase enzyme, DNA polymerase enzyme activity and formation also. Next, by inhibiting RNA polymerase. Okay, so what are the different examples? You can also inhibit nucleic acid synthesis by inhibiting reverse transcriptase enzyme. And next is by inhibiting metabolic pathway. Okay, so by inhibiting metabolic pathway also you can inhibit the nucleic acid synthesis. Now let's see the first one. Okay, first one, that is inhibiting the DNA replication. So the drugs or antibiotics which are used in the inhibition of DNA replication are quinolones and derivative of quinolones such as fluoroquinolones, and you can also use novoviocin. Okay, so what are the examples of antibiotics used in the DNA replication? Quinolones and fluoroquinolones. quinolones and novobiocin. Okay. Next, number two. Number two is DNA dependent RNA polymerase. So by inhibiting DNA dependent RNA polymerase. What are the example used? What are the antibiotics used? Example of antibiotics are indinavir, next sekinavir, next ritonavir. Indinavir, sekinavir, ritonavir. Next, by inhibiting the RNA dependent RNA polymerase enzyme. So RNA dependent RNA polymerase. So what are the examples? The RNA dependent RNA polymerase, only one and only one, that is remdesivir. Okay, remdesivir. Next, by using DNA polymerase enzyme inhibitor. So inhibit DNA polymerase, and the antibiotics which are used, acyclovir, next is ganciclovir, next is abacavir. Okay, next acyclovir, ganciclovir and abacavir. Next, RNA polymerase, this is DNA polymerase inhibitor. Next, by using RNA, by inhibiting RNA polymerase, so use an RNA polymerase inhibitor. And the example of RNA polymerase inhibitor are actinomycin D. Next, you can also inhibit the reverse transcriptase. So by inhibiting reverse transcriptase enzyme. So what are the examples? So example of reverse transcriptase inhibitors are zidovudin, next lamivudin, zidovudin, lamivudin, next stabudin. Next is stabudin. Okay. Next, by blocking the metabolic pathways, that is metabolic pathways blockers. So what are the example of metabolic pathway blockers? Metabolic pathways blockers. So example of metabolic pathways blockers are sulfonamides and sulfones. Sulfonamides and sulfones. Sulfonamides and sulfones. Okay. Next, you can also use PASA. PASA means para amino salicylic acid. Next, ethambutol. Next, pyrimethamine. Pyrimethamine. Okay. Thank you. So if you feels like watching my lecture is worth it, then please subscribe. Thank you.